Okay, with 7.4 we're going to solve inequalities by graphing. This is something we've been doing for a really long time, since algebra. I know you've been doing it. So it shouldn't be too new for you. One thing we definitely want to make sure that we have under grasp is that whenever we have our inequalities, we always want to shade. If I'm greater or greater equal, I shade above. And whenever I am less or less equal, I shade below. Now, you're definitely welcome to pick test points, but that's a lot of work in my opinion. I prefer common sense, shade above it or below it. The only exception to that is if it's a vertical line, to the right is greater, to the left is less. So here we're going to look at y greater than or equal to x squared minus 1. You can use your calculator and you can come up with some exact points. However, it's fairly simple to do in your head, but you can definitely use your calculator. You should know this is your k, so it starts at -1. And then just pick a couple other points. If I picked +1, that would be 0. So if I picked -1, it would be 0, because it's symmetrical. If I pick 2, I get 3, because 2 squared, and so that means it's going to be the same thing on the other side, and that's enough. How do we connect these points? It's going to be solid. That's what step number 5 here is about, is decide whether the line, how you connect them, is solid or dashed. In this case, it's going to be solid because of the equal to. Solid line is less equal, greater equal. Dotted is just less and greater. Then it's a matter of shading. Because this says greater, I go to the vertex and I look at greater. Greater is above. So I shade above, which in this case happens to be inside of the parabola. All right, on page 2, here we have x minus y less than 2, x greater than or equal to -2, and y less than or equal to 3. When I go to look at the graph of this, the first thing I want to do is I do want to solve this. So I'm going to make it -y is less than -x plus 2. And when I divide by negative, I switch my signs. So I get y is greater than the -2. -2 and my slope. Make sure you go far enough, because you definitely want to make sure that your lines are going to be intersecting. Vertical at -2, and I'm going to connect those with a dashed line because it's greater than. Shade above. Now I have x is greater than or equal to -2, so there's -2. It's vertical and it's solid because it's equal. And greater on a vertical, everything greater than -2 is to the right. Y less than or equal to 3 is horizontal, so I go to 3. It's going to be a solid line because of the equal to. Again, make sure my lines are crossing each other. And less means below. So then what I need to do is go back in and color in completely the shared portions. Go all the way corner to corner where they meet and make sure that is completely and clearly visible where it is that they overlap. Don't just draw these lines and think that I'm going to be able to see those. So I want you to go back and clearly shade in all of the pieces. All right, on example number 3, in this case when we do our lines, solve for y, we get that they have the same slope, so that means they are parallel. But if I'm unsure, I can definitely check it. I'm going to have dashed lines. The first one is above. Second one dashed. And below, and we see that they don't overlap. Because the slope is parallel, there is no intersection between the two. An unbounded set. What makes an unbounded set is that it is not on the third side. On the very first example we did, it was bounded because all three sides were closed off. The no solution, they weren't touching. But with the unbounded, I have two sides that are touching, are closed off, but this third side is not. So that's all it means for it to be unbounded, but it doesn't change what we do. We graph our lines and we see where they overlap. All right, on page number 4. Page number 4 is very similar to that break-even point that we have done in the past, but this time it's called the point of equilibrium. The point of equilibrium is where does the surplus meet the consumer demand. At what point does producing something and the demand for something meet? And that's what we're talking about here. Where they meet is called that equilibrium point. Now, on the example that it has on page 5, the first one is the consumer demand, and the second one is the supply or the production. And if we want a break-even point, we set them equal to one another, and you can solve for x. This is the point, the x point that they meet at. I then plug it in, and I can find that production value, the price in dollars. So in this case, if I were to draw the picture out, at 3 million units, they meet a break-even point of $120. So if the price drops, does consumer drop? Does productivity drop? How does that work? What happens when I produce more units? What happens to the price? If I produce less units, what happens to the price? So that's what that information is talking about. So that's your break-even point. That's your graphs. Graph them, decide where they intersect, find those locations, make sure it's very clearly marked where it is that's being graphed. Are they dashed lines or are they solid lines? And just be clear with your graphing.